So we're dealing with quadratic relations. So we did just a small little lesson at the beginning of the unit on quadratic relations. So remember those U-shaped graphs, those parabolas. So now we're just going to dissect the points and what they mean, okay? So what they mean in a parabola, all right? So the first one is the vertex, okay? So the vertex, if you think of it, or vertice, if you think of it in a triangle, it's that top pointer, right? Or that uppermost point. Or if we were referring to maybe the bottom point, it's that point in which it changes direction. So in a parabola, it's going to be the very bottom point or the peak of that parabola or the low of that parabola. Okay. Now the axis of symmetry. So if you think of the two big words there used, so axis, we use our y and our x axis, okay? And symmetry, meaning that it's the same on one side as it is in the other. So with parabolas going typically like this or like this, if we want it to look exactly the same, if we were to cut it in half, we're going to add this little line or this axis that's kind of like an imaginary y-axis, cutting the parabola in two. That's what we mean by the axis of symmetry, okay? And it's found on the x-axis. So we'll get into a little bit more of what that means, but basically we're cutting that parabola in two. So maximum value means if the parabola is going up like this, and it has a value up here, so that would be maximum. And then the minimum would be the opposite of it. So the minimum would be somewhere down here if it was a U-shaped graph. So if it's kind of like a little hump or a mountain looking thing, then it's going to have a maximum. If it is a U-shaped graph, then it's going to have a minimum, okay? So that minimum is just the point in which it goes down, and I'll show you how we're going to do those things. Well, the y-intercept, that's nothing new to us. That's just where the parabola or the line crosses the y-axis. And then the x-intercept is something that's going to become very familiar with you guys next year especially. And another word for this on a parabola are the zeros, okay? So it's basically the point in which the parabola hits the x-axis, and typically it's twice unless the vertex is right on the graph. Okay, so we're going to take all that knowledge we just learned and we're going to put it onto this graph. So the first thing it says is examples. Determine the characteristics of the following quadratic relations. So it says coordinates of the vertex. Well, if we look at our graph, this point right here is the coordinate of our vertex, or that is the vertex, sorry. And if we did the coordinates of it, remember coordinates being x comma y, we'd follow this on the x-axis to 3, and we go down to -4. So our coordinates of a vertex would be 3, -4, okay? Now, the axis of symmetry is going to be when we cut that parabola in half. So it's actually right on the vertex is we can cut that in half. And when we do that, the axis of symmetry is going to be relevant to the x-axis, okay? And where is it cut on the x-axis? And in this case, it's 3, okay? So the axis of symmetry is actually equal to 3, okay? It's just how that's cut in half. Now we're dealing with maximum and minimum. So I said when we have maximum, it's like this, and we have minimum, it's like that. So the minimum value, okay, is going to be what we're looking at. So it's basically that point in which is further down. And in this case, we're going to use the y-axis to help us. So the minimum value, or how far it goes down, is -4. Okay, and it is a minimum. Okay. Now the next question is y-intercept, and that's really simple, guys. We know this. So the point in which it crosses the y, or it intercepts with the y-axis, is 5. Okay. And now the cool thing, the x-intercepts, or the zeros is another word for it, are these 2 points that meet the x-axis. And in this point, it would be 1 and 5. Okay, those are our x-intercepts. So we've looked at this parabola, or this graph right here. That standard graph is at x squared, but it's obviously changed around slightly, or transformed. And we've been able to dissect what we have here. Okay. All right. I'm going to get some help from you guys for the next question. So you can use that stuff above, but can anyone help me out with the coordinates of the vertex? Yeah, Georgia, go for it. Yeah, so -4 and 2 is the coordinates of the vertex. So you've gone along the x-axis and then up the y, so -4 and 2. Can somebody help us with the axis of symmetry? Someone else? Okay, Georgia, go for it again. Yeah, -4, so it's cut in half, right? Right at -4. So -4 is our axis of symmetry. Someone other than Georgia, can you do the, is it maximum or minimum, and what is the value? Brady, can you help me out there? Okay, so it would be 2, correct? And is that maximum or minimum? Correct. So it's maximum. Awesome. And that's 2. Wicked. Okay, someone else. What's our y-intercept? Y-intercept. Super simple. Somebody who put their hand up. Jay, go for it. It is -6. Awesome. And then someone else, what are our x-intercepts or our zeros here? X-intercepts or zeros? Somebody that hasn't answered something yet. Yep, Paige, go for it. You got it. -2 and -6. Awesome. Well done. Okay, so that's pretty straightforward. I'm just going to do the last one for us since there's not too many eager bodies here, but the coordinates of the vertex being right here at the bottom, would be 0, -9. The axis of symmetry happens to be right on that y-axis, and where it fits on the x is at 0. Since the graph is that U shape, it's a minimum value, so minimum, and the value itself is -9. -9 seems to be important in this question because it's also the y-intercept, because that's where it crosses the y-intercept, right at 9. And then our x-intercept, or our zeros, fall at 3 and -3. So is 3 and -3.